How's it going, everyone? Welcome, Olivier Gonzalez. There you go. Now, I just want to make a quick recap, as usual, of how do I get here to actually get a sense of what we're going to do about it in this React course. So, over the couple months, I had took I had took notes of this thing called React to understand what it is, why does this even exist, and why this is useful, and why a lot of all companies actually are looking is for people that know this tool or have experience about it. But most likely that they have experience working with this, working and building with this particular tool. Why is that? Well, because they want to create now user interface much more engaging and easy to implement and debug and maintain, based on all the heavy lifting done by Facebook team, and now formerly Facebook, now Meta. So the whole idea is that by first understand first, how do you learn? How in several papers about, well, where are the several techniques of how you can learn more efficient, effectively, yada yada yada. But the TLDR is that if there is not the desire to learn, don't even think about it. In fact, forget about this. However, if their desire is genuine, all right, now the how will opens up. And this is why I'm actually recording this kind of videos, to not only take notes of all of this, but to, since English is not my main language, I do need to find words and see how the English, and how can I articulate my ideas much more quickly and precise for myself, and also if I'm going to offer solutions to X, Y, and Z clients, right? Now, speaking of solutions and stuff like that, so React was a solutions to a problem that Facebook had back in 2011, when they have now a particular piece of information, aka an state, that they wants to now that they share across different user interface. So because now they use the MVC model, so they need to now update is this state in all of the other places when that is being used. So it's actually make a pretty complicated issue to triage which state we need to update and in which view. So React say, hey, instead of the R&D at Facebook say, hey, let's gonna now have is one single place where we can keep our state sync with the UI. So no matter which UI is gonna use this piece of information, all right, we just only care that to update that state or that data. And that's what React now is so powerful, is this idea where this is not only work for on the web, but any UI that you want to develop in any platform. So React Native is one of them. The WebLG, the WebLG on the browser as well. So in our case, in order to understand this specific tool, I look at how to build now your own React application, especially on the web, by now creating is a function that anytime that you pass now a certain properties, and in this case, working with the HTML element, is anytime that you pass now some props and attributes or content, you want to now generate is now a new HTML with that new data, right? This is the core of React. And because this can be quite tedious to write, because, since anytime that you want to create is a new state of the UI, you have to call that function. And in the case of React, you say, hey, React create elements, and this is what I want you to build for me. Okay. So GSX come up with a solution to say, hey, since at the end of the day, the only thing that we care is to write these user elements, it makes much more sense for us to say, let's going to write HTML and CSS in the same file, aka GSX, okay? Or JavaScript extends. So now we have is the style or the markdown and the logic in one single bundle. So because this new way of creating user interface is completely different of how we have done in the past, or how you done without React, which is you define the markdown and then this CSS or this style, the look and feel, and the behaviors via the CSS, via the JavaScript. So all of these are different files in order to now provide that user interface. But in the case of React, everything now is on a single file, right? This is known as the component-driven or the component-driven web development, where everything now is a bundle. And just to mention that this kind of complexity might be useful or not, depend of the use cases. So for example, if you're building some small applications on the internet and you only want to do that using its HTML, CSS, or JavaScript. However, if that application now scale to provide now more interactivity and functionality, and at the end of the day, if you want to now suck the light of your users, it's just a matter of speaking. It's just a matter of speaking. But the thing here is, if you want to now have a business on the internet where you have recurring clients and pass through all of these phases on the user life cycle. So you have now the users, the retention, and then the user retention, and the user conversions, and then the user lifetime value, and so on and so forth. So all of these specific metrics that are relevant for building web APIs. Okay, this is something that I'm going to do to build at least a small applications to make a sense of all of these things. So to have a broad sense of what am I talking here. So, but in any case, the thing here is this: is now with this new way of writing web applications, okay, I look at the anatomy of this component, which is at the end of the day is just made of a JavaScript function. When you define is the markdown and the styles, all right. And what is the difference between this GSX versus HTML, and the GSX versus templated language engines like Blade or Blade for Laravel, or Liquid for Shopify, right? Or for Ruby. The convenience here is that there is no need for a particularly templated language or a specific logic, since we are using now is JavaScript to do so. That's kind of the compelling stuff here. So I also look at how can we create these components, how is this component is generated, what this component is transformed into at the end of the day, which is now a JSON object. So anytime that you call or you create now an object, okay, what you are doing is creating is a JSON-like object that describes the UI at that specific moment. And I also look at these convenient function built-in React components called fragments that help you to avoid polluting the globals or the DOM. So in terms of now look at the anatomy of the components, in which is, hey, this is a particular function. We receive now some props in the children as well, which is the nested content. All right. And then we can generate, or we want to generate some specific markdown. So this, when React now call those functions for us, it will create now this new state of the UI in a JSON-like object, right? So the anatomy of this JSON object is that, hey, is that, hey, we have now a key, we have now an ID, we also have the props, and we have the children, and also some additional property that are not relevant right now. So this key, especially when you generate now a collections of elements, so React unfortunately doesn't keep track of all of these elements for us. So we have to be explicit about when we map over elements, when we generate a list of elements, which is a lot of the time what we do as here on the front end. Generate a list of elements or collecting data from a form. So when I also look at the different way of how to render conditional elements, how do I conditionally render elements here? Which is, let me take now is the oh my god, yeah, when I do want to conditionally rendering elements here, a lot of the time you can is whether it's using the if earn, the early return of the if, all right, or the ampersand or the and, or using the ternary operator, using the question mark. Now, what I mentioned here is that despite all of this different way of how to rendering elements and the nuances, all right, so why it is preferred to always use a boolean rather than a truthy or faulty value, and anytime you want to add the look and feel of that user element, using now CSS, especially with the CSS model, is the way how you can now get those elements inside of your React component. And by defining is this series of CSS selectors, you can now is call them like if an object in your React component. So this is just to summarize the model 1, okay? And then on the model 2, which is, okay, so how do we now respond to user events? Traditionally, without React, or prior to React, there are two ways to respond to that event. Whether it's you attach a function call to an event listener, all right, on that HTML tag, or you attach now a function reference to that event via an event listener. So why this is important, right? Because the way how React does is by calling them those functions for you, or aka those handlers for you. So here we now pass is the function reference defining on our component, and it's up to React to call our functions for us. In this particular distinction is something that one of the founder of the Agile Manifesto that he is currently working at ThoughtWork, a IT company, Chicago based, that has now a tech radar that every 6 months they release now some of the language and platforms, as well as the tools and the techniques uh, in this technology radar. Martin Fowler, when he mentioned is that when your application, when a function is called for you, is this is this is what a framework does. Again, what he's describing is this inversion of control, aka, which is a fancy way to say, hey, um, what happened when somebody else call my functions, when I don't have control of when the function will be executed. So when that happens, so now this is usually handled by some sort of framework. So something that you don't have control over that. But when you call your functions, this is now called a library. Why this distinction is quite useful and important? Because as we write our applications and we try to respond to user events in React, by passing now a function referring, not directly calling the function, this is what this framework or library like React is doing for us. A lot of people actually call libraries and frameworks, and most of the time they don't have even the notion of what these things even means, and I don't blame that. But if you have experience in this field and you have a lot of years, you at least must know that difference. But that's what it is. So this is important because when you want to now is adding interactivity to these user components via now a particular hook called React State that allow you to hook into the internal of React. Particularly this hook allows to remember piece of information in JavaScript. And you might think, you might wonder how this is, how this even possible. How do you now preserve some sort of information in your season, in your tab, as long as you don't refresh? How do you preserve that piece of information that stayed there, right? And how you can now access and update that piece of data. This is known as closure. This go beyond the scope of today's video, but I do think this is useful in terms to understand now not only what React is, but also what this JavaScript is all about and the intrinsics of the tool. So in any case, this particularly hooks allow us to hook into React to remember piece of information. So I starting to understand why this thing might be quite hard for some folks. But again, if this is something that it was made by humans, so this is not an alien thing, you know. What I do, what I meant, what I want to brought here is that because you need to understand is all of this basic little stuff that's happening behind the scenes, and that is how a computer works, what it does, what is the hardware, how this hardware works, and then how you can now uh, let this hardware to do some stuff in the real life world, right? So for example, to compute, uh, so to add, to subtract, divide, multiply, right? And then now do some more complex stuff like logic and so on and so forth. So this is why I mentioned this stuff. So, but in any case, closures is something that allow you in JavaScript to remember the informations uh, when you now access to a variable that live outside of the function scope, even if this function is executing in a different place. I know that this might sound a lot of gibberish in Chinese for a lot of people out there, but the TLDR is that this specific hook that is provided by React allows you to remember stuff. And any time that you want to now respond to some user events to update this piece of information via this hook, you do that now is inside of these handlers. And these handlers, because they are called by React, not by yourself, so it passed now through this React event or the React core loop, which is anytime that this state is updated because you want to update that state and it returns you now is a tuple. React give you now is the value and the function, the setter function. So now you can is update that value inside of that event handler. And what happened is that React internally is going to detect which component called that which component called that state, and then now run, so that you're gonna trigger, it's gonna detect which component trigger that state update, and then it's gonna render. And in the case of React is, hey, let me generate is this new state of the application by calling that function that triggered that state and all the subsequent components, right? So once I have this new JSON object that has the new state, so now what I can do is to apply only the bare minimum necessary DOM updates, which is known as the commit phase, and then let the browser handle that for me. So this is now known as the painting phase. React is not involved here, because when the browser detects those small changes on those UI elements, let's say you change the class value or another attribute on the HTML, right? So, but when the browser detects those changes on the HTML, it's going to now trigger is the UI update in that specific point on the screen. So this is the core loop, all right? And these core loops now started to make a lot of sense, especially when you when I read things about what Martin Fowler mentioned about what is the difference between a library and a framework. So it makes a lot of sense now how the things work, all right? And again, it is up to you to decide if you truly want to understand this and what the thing is doing. So, but in any case, I find that out very, very, very interesting. Very, 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 very interesting and revealing. Is revealing. So in any case, so this is the core loop, all right? So also, most of the time, because we want to now not only render a list of elements, but to collect data from user inputs, So we use now forms. So this specific forms that you have is now input radio, button, checkboxes, select, text area, uh, type text, password, hell, you name it. Because there is no a consistent way to get that value and update that on the DOM. So React team say, no. Let's going to now create is a unified API, for example, for select and for inputs, that anytime that you want to detect when a change happens, you use on change, and when you want to update that, uh, you now use the value attribute to that. This is known as a two-way data binding. In the case of radio buttons, the story is say, hey, let's go into now select the value and check if that value is the same as it is as true or false, you name it. So I also look at that and how to create your own forms using that, for example, with range and so on and so forth. That was quite illustrative, quite interesting. And another thing is that when you are writing is more complex states to represent more complex data, all right, it is preferred to always return is a new state out of this. Why is that? The TLDR is that ask yourself, how can you make sure that two nested objects, all right, are the same in property and values, right, in key value pair, right? So you have to actually iterate through all of this, and if that has nested up, you can also iterate through all of this. Another thing is that you might is trying to convert that two object into a string, all right, and hopefully guarantee that the order of these two objects, so guarantee that they are sorted, all right, and if they're sorted, well, you can now spot what is the different values that one have versus the another. So in other words, in each of those scenarios, the least time complexity is linear time, assuming that both of them have the same, so both of them are sorted, all right. If you do a linear search, so it will take you now n amount of time, right? So you might not want to do that, right? In fact, because this is actually something that is going to be CPU intense. It'll be intense for CPU wise and memory. So the TLDR is that, hey, let's go into now, because memory has become more cheaper than CPU. So let's take now is a new state out of that. So create now a new state that you want to update for that. So that makes a ton of sense. It's actually quite interesting. And this is how we deal with this state that represents large information, right? A nested object and so on and so forth. So, but in other words, if we don't want to do that, and for some reason, if you find yourself in the need to have is nested objects inside of your, to handle that state in your application, which is something that you shouldn't have, you can, but you shouldn't have. There is no need to do so, right? But if you find yourself in the need to now build an application or a POC that is pulling a lot of data, and that data that comes from backend is not treated in the proper way, well, you can use is IMER to help you to now create and update is the new, or to generate is the new state, especially on nested deeply objects, without having you to do that manually, right? So, but in any case, I do think that's quite interesting, quite compelling, as a way to understand why we don't, or why we need to generate a new objects anytime we update a new state. So how to deal with all complex objects, okay? And the other is, well, now that I know that, how can I guarantee myself to generate is a unique key anytime that I render is a list of data, right? So there are a couple ways to do that in the front end, right? Whether you're using is the mat.random or the crypto.getRandom UUID, which makes a lot of sense to do so. And anytime that you create that, you do that any time that you create now a new object as it is. So this actually guarantee that you will have a almost unique value, because the odds are astronomically low to generate to have a collision. So yeah, to have a collision here. Now, yeah, that makes a lot of sense, right? And after that, right? I also look at how can we now deal with that state in terms of React applications. So where do you need to put your state as a way to now pass down that state or not? And when you choose where to put it, it is it's going to have an impact overall on the overall performance in your app. So depending on the type of data you want to store and what data you want to represent, some applications might have or not the need to have a central store or an state management. So for example, if you're building out some landing pages, all right, you might not need to have an state management. However, if you're building out heavy intense applications like games and so on and so forth, so any heavy client applications, well, having an state management, it makes a lot of sense, right? And when you are now building is back office application, which is a lot of the time what you're going to do or end up doing to helping this kind of business to most of this or the companies that I have worked in the couple years, they have now their own data stored in somewhere, right? Some sort of database or data warehouse, whatever they want to call it. And they have now a particularly dedicated data analyst team to ask the question is that what are the problems that we want to solve, what are the KPIs or any other indicator that they want to pull out of this data, okay, and what is the query we need to write in order to do so we can now pass that to the backend or even ourselves, right? And with that, all right, then this is this data that we need to show to the user. So on the backend, or most of the time it's on the querying in itself, it already have all the necessary piece of information needed to show them to the user. So because this particular assembly line, when you have now the data analysis senior analysts, data chief analysts, or chief information officers, and then on the operations, and the front end and the back end, you have front end and back end, right? So most of the time, if you want to improve your queries, um, write queries directly through the database. There are also some ways to avoid some common problems like SQL injection and so on and so forth. But don't do any data manipulation on the backend. It's not. It's not. And if you find yourself doing that, well, at some point in the future, if that product live long enough, they will have to rewrite that particular query. So, the TLDR of all of that, right, is that because most of those apps that we as developers are building for X, Y, and Z companies, they already have the data stored in some of any of these databases, Redshift, Postgres, SQL, MariaDB, whatever, okay, MongoDB, and we as a front-end developers and also full-stack developers, we need to is get that data, so query the data, get that, and then now present that to the user in a compelling and in a convenient ways according to the business rules. So now we need to deal with couple issues here. So for the React, since React is meant to build user interface, so here you are need to. So there's certain challenge. First is that, okay, how can I call is the right data at the right time? That's one. And then how do I know the state of the request? So if subsequent requests are sent, how do I cancel that if that is needed? And the other is, how do I catch this data from a stale one so I don't need to hit the server again? And I think this is the three main issues here. Yeah, I do think that's the main three issues here. The three main issues here. There are several. I know. There are several. But it's. Exactly. This is what I'm describing here with these different application types, right? So not much state in landing page, in home pages, with app state, or with app or client side app. So you might want to use that. And when most of them are on the server, well, how do you handle that, right? So mostly server state in this category is primarily for crude operation and so on and so forth, right? Or for SaaS application, social network, search engine, e-commerce site, etc. So all right, now let's define three categories and let's talk about why they matter. The right tool for the right job. So the reason I think it is valuable to split apps into this category is that the challenges are different. So as I mentioned, the category 1, you don't need to. For category 2, Redux is awesome. But for the 3, which is now server heavy applications, okay? Yeah, server heavy applications in category 3. The biggest state related challenge in this category are all network related. All right. Okay. And all of this network related. Okay. Let me. I'll be quick. So I mentioned this different. I mentioned is the entire assembly line that happens from the DB and data wise to the front end. So here there are several roles involved. So you have the data analysis. So first you have the shareholders and the CEOs and the decision makers, right? So they hire now some data analysts to say, hey, I do want to take a look at this huge collection of database, all right? And then now query that to get some insights based on these questions that our shareholders are asking. Okay, so this is what most of these CEOs are doing, or C-level suites are they doing in those companies, right? So far so good. Now, what happened is that those analysts go to the database, right? And they query that whatever database they're using, DynamoDB. Let me actually write it down here a little bit because I do think this is convenient. I do think this is convenient, man. This is convenient for myself. Exactly. But this is now the state management tool. State management tools. All right. So I'll 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 describe I'll describe why I'll describe how you as a software engineering fit here, fit in a company, right? In a company. That's what it is. So I'll describe how you as a software engineer fit in a company. So C-level suites or I'll describe how you as a software engineer fit in a company. Companies, not startups, okay? Companies, not startups, they have already large amount of data collected prior your arrival, right? So shareholder, so C-level suites wants to answer the questions of shareholders in terms of business value, key performance indicators, so on and so forth, and so on and so on and so forth, right? So C-levels tells or C-levels indicates data analysis, exactly, data analyst, right, to query data to query data. So C-level suites indicates C-level suites indicates to that analyst querying data query data to answer shareholders inquires. Okay, so C-level suites indicates to data analyst query data to answer shareholders inquires. So based on this analysis, and based on this query analysis. All right, here we go. So based on this query analysis, and the approval of the C-level suite, all right, to meet business and shareholders value, is now when the software engineer can describe or can build or maintain a web server and a frontend app to pull the proper data and fit into the web app. So users can solve their own problems. Oh, exactly. Or so users can see features that solve their own problems. So this is what you can summarize is the software engineering over the entire pipeline here. Let me actually ask Claude about it. All right. Yes, sir. That's a reasonable description of one common workflow in established companies, though the reality is often more nuanced. Let me explain on this. What you have captured well is the shareholder, C-level, and teams and products. The data-driven decision-making process and the roles of data analysis is inform business decision and informing business decisions. Software engineering implementing solutions based on validated business needs. Exactly. And software engineering implementing solutions based on validated business needs. What's often more complex in practice is software engineers in mature companies typically wear multiple hats beyond just building what's approved. Discover and ideation. Engineering often identify technical opportunities or problems before they bubble up to C-level. Usually, engineering often identify technical opportunities or problems before they bubble up to C-level. Architecture and maintenance. Much of the work is maintaining existing systems. Mm-hmm. Architecture and maintenance. Much of the work is maintaining existing systems, managing technical debt, and ensuring scalability. Cross-functional collaboration. Engineers work directly with product manager, designers, and sometimes even customer, not just waiting for top-down directive. Exactly. So innovation. Many companies have room for engineering to experiment, propose features, or improve system without explicit C-level directive for each change. The feedback loop is multidirectional. Engineers might notice patterns in user behaviors or system performance that inform what data analysts should examine, which then informs C-level strategy, which then influence future engineering priorities. Your model best work best for major strategy initiatives, new product lines, compliance-driven features, and research-intense projects requiring executive buy-in. According to this, okay. But again, this is a lot of words from that. So this works for major strategic initiative, new product line, which is anytime you are on a POC, this is what it is. Compliance driven features, this is what companies are, right? This is what a companies are, right? So company workflow. This is the company feature workflow, right? Company's feature workflow, right? It's mainly this. But in the case of startups, you don't care about scalability and all that kind of stuff. You just only care that things actually work as expected, no matter what. Mm-hmm. Holy moly, bro. Mm-hmm. So why I hit the brake here with this? It's just to make sense of what am I doing, by the way, and what are the challenges and the problems that we are looking for, and we're trying to solve and save us as a big company, or when you're working for a large company. Okay, that's mainly the workflow. C levels you want to so C level suites ask for their data analysts to answer the shareholder questions, and based on their queries and insights, see the feasibility of that. And if it is, all right, now let's go to talk to our IT department and explain what are the things that we need to do. So hey, this will be now a new POC or a new line of business, a new strategy, but it's up to them with the engineering and the team, whether it is the product, the design, and the engineering itself, is to hey, um, this is what I'm going to do. This is what needs to be done, and as an engineer, we are now handling the backend and the front end, pulling the data from the database based on what this query analysis, based on the query analysis made by the data analyst. We double check that, we see what needs to be refined in order for us to now improve the user experience. They don't have to wait too much time, right? So improve the user conversion and retention, the retention and conversion. And then, well, you actually is delivery that. So this is the company workflow from a software developer standpoint, right? So from a exactly this is the company workflow for a software developer wise, okay? But when you're building now applications with React, user interface with React, not with Java and all that kind of stuff, right? With JavaScript and React, this back office apps, which now the state leaf is on the server and also on the client, now this becomes these are network problems. First is to fetch the right data at the right time. Okay, making sure that that data doesn't grow stale. So by revalidating or fetching it again, and specify when and specify is when we revalidate that, specify the circumstances to revalidate that data. Okay, and make sure that we don't make sure that we don't hammer in the API by catching the data. Okay, and then now do this optimistic UI, which is how do we predict that future requests will resolve, or how future requests will resolve. Is that, hey, what happened when I send out this request, and if that request, how this request will be resolved, especially when I send a new one, or the user now, for example, wants to search for a new criteria. All right, a good example is on the search term. How do I do that, right? How do I now is resolve those future requests? How network requests will be resolved? This is the optimistic UI updates. And the other is the pagination. So it makes a lot of sense here to describe here. So here's the thing. So Redux doesn't do that because it is a state management, not a network management. Now, because the Redux tool say, hey, let's going to write this convenient extension known as RTKey query that it will handle this network request issues. Okay. Don't get me wrong, you can go with that, but if you want a robust, somewhat mature and well adopted by the community library to solve you these particular problems, so you have now Apollo, which is what is currently this app where I'm working right now is using, or you use now React Query, or you use SWR from Verso. But whatever you want to go with, all right, this is what needs to be done, right? So Apollo, React Query, or SWR server, and the problem they solve are network related. Okay, it's like, hey, how do I make sure that I fetch the right data at the right time, and that data doesn't grow stale? So AKA I need to revalidate that and provide the specific conditions where I need to revalidate that or to do so. And also is I don't want to hammer in my API. I want to now is catch those data. So I don't need to I want to catch that data here. And also is how now from our components, how can I from component wise is to determine how this data will be how this request, or how can I predict how this request will be resolved, okay, with this the optimistic UI state, which is race conditions. So what will happen, and how do I solve this race condition? How do I predict that this how do I predict that this network request how do I predict how the network request will be resolved? Okay. Hey, I'm sending this piece of information, okay, and And if I send another one, then another one, and then another one, I do find ways to predict how that request will be resolved, right? If it need to be discarded and so on and so forth. Uh, and I understand why there is a heavy push for aborting the requests. In fact, I think that the abort API request is there. Abort controller here. Abort method of the abort controller interface aborts an asynchronous operation before it has completed. This is able to abort fetch request, the consumption of any response body or string. Reasons optional. The reason why the operation was aborted, which can be any JavaScript value. If not specified, the reason is to set its abort error, dumb exception. See the abortion signal page. And this was something what somewhat introduced quite recently. Aborting fetch operation using an explicit signal. The following snippet show how we might use a signal to abort downloading a video using the fetch API. But this is if you want to abort downloading a video. Aborting a fetch operation with a timeout. Aborting a fetch with timeout or explicit about. Implementing an abortable API. Signaled okay. And when you detect now this event, because it's now an event, holy moly. Oh, this is now an event from the DOM. Holy moly. Okay. Okay. All right. Okay. I do get it. Okay, I do get it. So, but the abort is setting there. An abort controller. So in any case, this is not what is this, right? But yeah, that's what it is. So that makes a lot of sense. And also, this is also why I do want to hit the brake here, because now I understand what is the problem that they are solving. Makes a lot of sense. Okay, I'll be right back.